So I'm going to teach you how to do problems with electromagnetic radiation. And I feel like it's really easy because it's just, you know the answer. The answer is always, for the first problem at least, is C, which is 3.00 times 10 to the 8th meters per second, because we always calculate in a vacuum. And then it's just the product of two things, lambda and nu. So this, we know the answer is 3.00 times 10 to the 8th meters per second. And then how these problems work is we get either this piece or that piece, and we're asked to calculate the other one. Now, the one thing where people have trouble with this is when you divide by a scientific number on one of these type calculators, you have to put the bottom number, the one you're dividing by, in parentheses. If you don't put it in parentheses, it's gonna, well, let's say, you're dividing by 6.56 times 10 to the 14th. If you don't put it in parentheses, it divides by 6.56 and then multiplies times 10 to the 14th, and your answer gets way off. So the easiest way to show you how to do this problem is just to actually do one. So I'm saying that, just out of my head, I have a frequency, which would be a nu. That's the one that looks like a V. Please don't call it a V. You have a nu of 4.36 times 10 to the 14th hertz. Okay? So that's our given. And what we want to know is what is the wavelength? So that's pretty easy. The C is a constant. C does not stand for constant. C is just the assigned letter for the speed of any electromagnetic radiation in a vacuum. There are other constants that we'll talk about, so don't think C stands for constant. It's okay if you did for a second, but not anymore. And so now we're plugging in here, and so what we have is we have the wavelength times 4.36 times 10 to the 14th hertz, and it's easy. You just divide both sides by 4.36 times 10 to the 14th hertz. 4.36 times 10 to the 14th hertz. Now I'm going to put parentheses around that. Forgot to put my hertz in there. So I'm going to put parentheses around that one, because this divided by that is going to give us, so that crosses off, the wavelength. Okay? So I'm plugging in 3 times 10, 3.00, but it's still 3. 3 times 10 to the 8th, and then divided by parenthesis 4.36 times 10 caret 14, boom, boom. And I get this, and your calculator may put it in scientific notation for you already, and if it does, that's fine. But 6.88, and I'm just going to count 1, 2, 3, 4, 5, 6, 7, and I knew that, but I wanted you to see how to do it. You just move that decimal point over. And that's going to be in meters. And if you're ever asked for that in nanometers, if you have times 10 to the negative 7, it just goes immediately into nanometers. Okay, so 688 nanometers. Now, there's nothing wrong with it. That's an easy problem to do. There's just not a whole lot else to explain. Now, the other equation is we can take any form that we know, either wavelength or frequency for, and we can find the energy. And so this is our other formula, and then this is a constant, h. See, I told you, C does not stand for constant, because here h is the constant, and that's Planck's constant. Max Planck, we're going to talk about him in a minute. And so the Planck's constant is 6.626 times 10 to the negative 34th joules seconds. And it's real easy. You just take your frequency and you plug it right there. Now, the mistake that people make is whatever they find, they just want to stick down here. But this isn't the frequency. This is the wavelength. And so you take the frequency and you move it down there. So 4.36 times 10 to the 14th hertz. And the reason why I put that there is that is the frequency. And then I'm just going to email that 6.626 times 10 caret negative 34 times 4.36 times 10 caret 14, and I get 2.89 times 10 to the negative 19th joules, and that's pretty easy. So as long as I have the frequency, I can find the wavelength and the energy. I'll give you a couple other examples in the next video, but I think that's probably enough for right now.